Alright, section 5.7, we're going to expand binomials. And what we're going to look at, it's basically a shortcut that you can do this. Now, the long way to do this, that we're not wanting you to do, is to do the full method, where you'd have to do it over and over and over and over and over on this one. For this part of it, what we're going to ask you to do, and we're going to kind of walk it into what we're going to do, is way back when, a long time ago, they were taking the smallest expression, the simplest expression, two-term expression you can come up with, which would be like x plus 1. And they wanted to see, all right, what if we took every expression of x plus 1 and did it to every power? So they start off with x plus 1 to the 0 power. So anything to the 0 power is going to make this 1. Doesn't matter what we put on the inside of that. If it's anything to that part of it, we're just going to make it 1. If we had x plus 1 to the first power, if you do something to the first power, it's just going to give you what you have here. So basically this would just be x plus 1. Okay, we do x plus 1 squared. That's when we'd actually have to do the full method. And again, we're going to just, to save time, we're not going to go back and do the full method. But we would have had x squared plus 2x plus 1. Okay, and then we could keep going through this. We could do x plus 1 to the third and keep working through this. But here's what we want to kind of see. Here's the shortcut we could do for this thing. Instead of having to do the full method over and over and over and over and over for each of the powers, Pascal and some of his, I guess you call them associates, some of his fellow workers, all kind of figured out that they started pulling out just the coefficients. And they noticed a little pattern here, that if you do something to the 0 power, that's just 1. Doesn't matter what it is. If we did x plus 1 to the first power, this was basically 1x plus 1. So they said, all right, well, that's 1 and 1. We've got 1x squared plus 2x plus 1, so this was 1, 2, 1. If we did x plus 1 to the third, without doing the full method a couple of different times, just to kind of show you, this would have been x to the third plus 3x squared plus 3x plus 1. So they said, all right, coefficient-wise, that's 1, 3, 3, and 1. Now, here's where they kind of started noticing shortcuts on this one. They said, okay, instead of doing the full method over and over and over, so we kept getting this longer, they kind of noticed the pattern here, that you can take the numbers above it, add those together to get the number below it. So we did 1 plus 2 to get 3. 2 plus 1 would also be 3. Okay, now for this one, if you do 1 to, what's 1 times anything? If you do 1, or sorry, what is 1 to any power? It's 1, right? Doesn't matter whether you multiply 1 2 times or 200 times, it's always going to be 1. So this last number is always going to be 1 to itself, so the last number here would basically be a 1. And same thing on the first part. If you do 1x times 1x times 1x times 1x times 1x, the coefficient's always going to be 1, but the power will change depending on what you do. So they say, all right, well, this one's always going to be a 1. To get the next number, we're going to add these two numbers together. 1 plus 3 is 4. 3 plus 3 is 6. And 3 plus 1 is 4. So if we want to do that, we could just keep expanding this thing out. If you want to do x plus 1 to the 5th, we're just going to put a 1 first, and then you're going to add these two numbers together. 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. 4 plus 1 is 5, and then we're just going to put a 1 at the end of it. And you can just keep going through those numbers, and you just keep adding those up. That if you want to get a 1 here, 1 plus 5 would be 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6, and then we put a 1 at the end. And if you notice on the wall over here behind AJ, there's every single one of those numbers just in a bigger form on the blocks back there. And what these numbers are, when they talk about the coefficients here, this is what they're going to call Pascal's triangles. That they found a little bit of a shortcut, that if you want to take x plus 1 to a power and multiply this thing out, that instead of having to do the FOIL method 5, 6, 7, 8, 9, 10 times, we can just take the numbers above it, add those together to get the numbers in the next row that would be below it. Now, and if you had to kind of go back and put this one together, if you were doing x plus 1 to the 6th, if they asked you to write this out with the powers of x, you would have started off with 1 or just x to the 6th. The next number would be 6, and then it would be x to the 5th. You basically just count it down. The next one would be 15, x to the 4th. Then we've got 20, x to the 3rd. 15x squared plus 6x, and then plus 1. Okay. But the main thing is that you've got this triangle, and we're going to show you how to kind of use this part of it here. Okay, and we're going to do basically 4 things to kind of get here. And there's really only one part of it that's got math involved. Well, maybe 2 parts, 2 small parts. Most of it's going to be just writing things down, and you'll do a little bit of math with the end of it here. Okay, so if we're going to expand binomials, the first thing you're going to have to do is, bless you, you're going to have to determine which row of numbers from Pascal's triangle you need. Okay, now to do this, it's really pretty simple. That all you're going to have to do is, when they ask you to expand, they're going to give you x to some power. So whatever power they give to you, the power that you have in the problem, you're going to have to use that with the second number in Pascal's triangle. So whatever power we have, that's got to be the same as the second number on the row. And the reason we use the second number, just to pull down a little bit, is the first number here is always 1. So that part's never going to change, so we're going to have to do something with the second power, or the second number. So if we're going to use, if they ask us, and we'll show you some problems here in a second where we come back and tie that back in. So first thing is we're just going to take out one of the rows from Pascal's triangle. Okay, second thing, you're going to write down you're going to write the first term in descending order, starting with the power that's given. And when you do this, you're going to write these answers, or write these numbers. Basically, you're going to write it underneath the numbers from step 1. So whatever numbers we have from Pascal's triangle, you're going to take the first term we have, you're going to write it in descending order, and you start with the given power. So if they told us to expand x plus 2 to the 5th power, you would start with x to the 5th power, and then you would walk it down to x to the 4th, x to the 3rd, x to the 2nd, and then just keep walking it down. So first row again, first step is, again, we're just taking out a row of numbers from Pascal's triangle. Not really doing anything with it yet. We're just taking out the row of numbers. These, you're just going to take the first term, which is usually going to be a variable. It's going to be x or y or a or b, And you're going to start with the highest power they give to you, and then you just work it down. And then step 3, you're going to write the second term in ascending order. And same thing as before, you're going to write these underneath the terms we have here. The big thing for this one is when you write this one in ascending order, you have to start with the 0 power. Okay, so the first term's in descending order, starting with the given power. The second term, again, underneath the first term here, underneath these, we're going to start with the second term and we're going to write it in ascending order. Just make sure we start with the 0 power. And so far you haven't really done any math, you're just writing down the different powers and different terms. Here's the last thing we'll do, and here's where we actually do a little bit of work here. Okay, for step 4, what we're going to do is we're going to basically go back and multiply each column of numbers together. And when you do that, you're going to get each term in the answer. So multiply each column of numbers together to get each term in the answer. So 4 things to do, and really the only math involved is in the 4th step, because the first one you're just taking numbers out of a column, out of a triangle. Second thing, you're just writing down the powers in descending order. Third thing is you're going to write the powers in ascending order. And step 4, that's actually where you're going to go back and do the math on this. Okay, now and there's 2 kinds of problems that we'll go through. One of them we're going to give it to you where it's one of those where it's without any numbers at all, where it's just both letters. And there should be something like this in the homework when you're going through this part of it. So here's where we're going to ask you to just do, we'll do like 3 different problems here. Okay, and when you do these, the one thing they're going to ask you to do is they're just going to ask you to expand. Here's a number, expand this. Now you actually have 2 options. You can either use Pascal's triangle, which is what we're going to do. They're going to probably in some cases talk about the binomial theorem, but to use the binomial theorem, there's lots of steps involved and there's all kinds of things you have to do. So for what we're going to do, we're just going to stick with using Pascal's triangle because it's a lot, to me, it's a lot shorter and a lot easier to get the answer without having to go through the steps they're going to ask you to do. Okay, so here's the first one. So let's do a plus b to the 4th power. Okay, so the very first thing you're going to do with a plus b to the 4th power. Since this is to the 4th power, you need the row of numbers from Pascal's triangle where 4 is the first number. Now again, just kind of flashing back here real quick. If this is our set of numbers we got for Pascal's triangle here, 1 doesn't count because the first row in every number, first number in every row is a 1. So you've got to have it so that 4 would be the next number past the one that's here. So for this one, we're going to use the row of numbers that's got 1, 4, 6, 4, 1. So whatever the power is that's here, that needs to be the first number besides 1 that's in the row. So since we've got 4 here, we're going to go with 1, 4, 6, 4, 1. Now when you write these down, leave plenty of room in between these because if you have it too closely together, it's going to make it hard to work the parts of it out here. So that power should always be the second number, because the first number will always be 1. Okay, then we're going to take the first term, which in this case is a, and you're going to start with that number, and you're going to start it with a to the 4th power, because that's where we start with. So this one's going to be a to the 4th. Next one is a to the 3rd. The next one is a squared, a to the 1st, and then we're going to finish out with a to the 0 power. And as soon as you get a to the 0 power, this is one of those you can kind of go ahead and scratch through this one and just call that 1. Because anything to the 0 power is 1, so you can really just scratch that out and just call it a 1. So there's the first term counting down on the powers. Then we're going to take the second term, which was b, and this time we're going to count up and just make sure you start at the 0 power. So that's going to be b to the 0, b to the 1st, b to the 2nd, b to the 3rd, and then b to the 4th. Okay, now, and if it helps you, here's where you can go back and just draw a line in between those numbers, because that's basically your columns. And for this one, we've got b to the 0, but again, if you want to, you can scratch that out and just call that a 1. Because again, anything to the 0 power is just 1. Okay, and now you're just going to take it and multiply it together. So just block out all the other columns and just multiply this together. So what is 1 times 1? It's 1 times a to the 4th. We'll just make that a to the 4th. Okay, then go to the next column. You have 4 times a to the 3rd times b to the 1st. So that's just 4 a to the 3rd b. And since there were plus up here, we'll go back and put plus signs. And then just multiply the next part together. We've got 6a squared b squared. Well, that's your next term. Go to the next one. We've got 4ab to the 3rd. And then the last one, we have 1 times 1 times b to the 4th, which would be 1b to the 4th, or just put b to the 4th. And that would be the answer that we're looking for. Okay, so if they give you one, it's almost one of those where if you have the two variables, it's actually a little bit easier because there's not really any multiplication you do. You're just basically just putting everything together for one term. Because when you do 4 times these things, you've got the two different variables, then it's basically going to be the same answer. All right, now let's give you one where we've got more than just a plus b. Let's make it where we've actually got a number in here. So for example 2, we're going to change it up just a little bit. So just doing 2 letters where we've got a plus b to the 4th, we're going to change it up just one slight little bit. Let's make it x plus 2 to the 6th power. Okay, so when we do these, we need the row of numbers that's got 6. Again, because we know the first number is going to be 1, so we need 6 to be the next number. And if we check that list, and again, it's over there behind AJ's head, we've got 1, 6, 15, 20, 15, 6, and 1. So that power has to match that number. Okay, so once we've got a row of numbers, we're going to start with x, and then we're going to count it down, so we're going to start with x to the 6th power. Alright, then we're going to go x to the 5th, x to the 4th, x to the third, x to the second, x to the first, x to the 0, which again you can just basically, if it's x to the 0, just cross that out and put a 1 in its place. Okay, now here's the part where, again, by the second term not being a letter, being a variable, it's just a number. So now we're going to count it up. It's 2 to the 0 power, to the first, to the second, to the third, to the fourth, to the fifth, and to the sixth. And then go back and draw lines through all those different columns. And it just helps. Sometimes if you get, especially if you get your numbers a little bit crammed together, sometimes it helps to kind of keep things separate, keep things straight. You don't have to draw the line in between there, but to me it just seems to help to organize it just a little bit. Here's the part we actually have to do a little bit of math. You have 2 to the 0, which we know is 1, right? Here's where I'd go ahead and kind of multiply these out. 2 to the first is 2. No big deal there. 2 squared is 4. And then from there, you can just keep multiplying by 2. If we do 2 to the third, is we're going up by power, we're going to multiply by 2 and make that 8. 2 to the fourth would be 16. 2 to the fifth would be 32. And then 2 to the sixth would be 64. So when your second term is actually a number, you're going to have to go back and kind of write out what those numbers are. And again, it should be easy because they're not going to be big numbers. It's going to be 2, 3, maybe 4. Because if they get much past 4, the numbers are going to get so big it's going to be hard to get everything written in to make it work out to be what it's going to be. Alright, and then just take it one at a time. You've got 1 times 1 times x to the 6th. That's just x to the 6th. Then go to your next set of numbers. You've got 6 times 2, which is 12, x to the 5th. Next set of numbers, you have 15 times 4, which is 60. We've got x to the 4th. Next set of numbers, next column there, we've got 20 times 8 for 160. X to the 3rd. Go to the next set of numbers. Next column, we've got 15 times 16, which should be 240. X squared. This one, you have 6 times 32. That should be 192. And then for the last column, we have 1 times 1 times 64, or just 64. And that would be the answer we're looking for. Okay, and we'll do one more. And with that one, we're going to do one small little thing different and just show you what happens if you make one small change to it. Because it's the same basic setup. We're just going to change one small thing. It's going to just make one small difference in the answer. Last example, we're going to do x minus 3 to the 5th power. So the key thing is it's to the 5th power. So 5 has to be, because 1's always going to be the first number. We need the row that has 5 as the second number. And if we go back and check that chart, it was 1, 5, 10, 10, 5, 1. So we have the power of 5, so we're going to match the 5 here. Okay, then we're going to do x, start with the 5th power, and then count it down. So it's 5, 4, 3, 2, 1. And again, we have x to the 0, but if we scratch that out, we can just say that that's basically just 1. And then we'll do the same thing with the 3, but this time we're going to count up the power. So it's 3 to the 0, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and 3 to the fifth. And just to help out, we'll go back and draw the lines in between so we can make sure we've got everything. Alright, now what you want to do is, before you actually multiply anything together, go back and actually work out this row of numbers with 3's. So we have 3 to the 0 power, which is 1. 3 to the first, which is 3. 3 squared is 9. And then just keep multiplying by 3. This would be 27. 27 times 3 is 81. 81 times 3 would be 243. Okay, now and if somebody's asking about the negative, we're going to wait to get the negative. We'll do it at the very end to show you how to get the negative in for this part of it. So taking the very first column, we have 1 times 1 times x to the 5th, so that would just be x to the 5th. We have second column, 5 times 3 times x to the 4th, so that would make it 15 x to the 4th. For the next column, we have 10 times 9 for 90, x to the 3rd. Next column, we have 10 times 27 for 270, x squared. Next column, we have 5 times 81, which would be 405, x to the first, or just x. And then the last column, you have 1 times 1 times 243, which was just 243. Okay, the only difference between the answers, if this was a plus, if it was x plus 3, everything here would be a positive. If it's x minus 3, basically it's this. You're going to start, the first one's going to be positive. And then from there, it's going to alternate positive and negative signs. So if the first one's going to be positive, which will be every single time, if it's a minus, you have to alternate. So we're going to go from positive to negative, positive, negative, positive, negative. And that's the only difference between x plus 3 and x minus 3. If it was x plus 3, they're all positives. If it's x minus 3, the first one's positive, and then you alternate plus, minus, plus, minus, plus, minus. You get finished out to the end of it.